So today we discuss polarization, last part of wave optics. So discuss polarization. Okay. So what is polarization? So we know that light is an electromagnetic wave. So there is an electric field and obviously a magnetic field. So know that diagram. So the 3D diagram, that is X, Y and Z, and electric field suppose vibrating that direction. So vibrate in Z direction. Okay. So that's the electric field vibrate in Z direction. Okay. So the plane of electric field are in ZY plane. Okay. So these are vibrate in Z direction, and the plane is electric field plane is ZY plane. Z vibration in Z direction and propagate in Y direction. So there is a magnetic field. You know that's the electromagnetic wave. That's a magnetic field, and there is a vibration. So vibration, particle or atom vibration or molecular vibration are in X direction. So B, magnetic field vibration in X direction, propagate in Y direction. So magnetic field plane is a XY plane. So there is a two plane here. Okay. So light is confined. If a light is an electromagnetic wave, we know that. So confined in two plane. One plane is represent the electric field plane, and other plane is represent the magnetic field plane. So when we discuss a polarization, we must know that light is an electromagnetic wave. Consider the light. Okay. So this plane, suppose we extend that is y. Suppose this plane. This plane. Okay. This plane represent a magnetic field plane, and top of that, okay, there is a electric field plane, and you see that these two planes are mutually perpendicular. See that these two planes are magnetic field plane and as well as the electric field plane are mutually perpendicular. Okay, so light confined in two planes because light is electromagnetic wave. So there is a two plane. Okay, so if you ignore, suppose let's say that if you ignore that is magnetic field part. Let's say if you ignore B, ignore B. So there is only a electric field. So electric field molecule vibrate in Z direction and propagate in Y direction. Okay. So the plane of oscillation. Okay. So that's the electric field plane of oscillation are in plane ZY plane. Suppose okay. Suppose that okay. That's the electric field, and the vibration in Z direction. Okay, so the plane is now, suppose the plane is there is a plane. Okay, there is a plane for electric field, and this is called plane of oscillation. This is called plane of oscillation for electric field. Okay, and this oscillation in one direction. These oscillation are in one direction. There is a vibrate in Z direction and propagate in Y direction. So they are obviously in one direction. Okay. So but in an atom, suppose in an atom, you see that is an atom. Okay. So they actually atom of EMF wave. So they do not vibrate in one direction, they vibrate the many possibilities. Suppose in that direction, suppose here in that direction, but this direction also possible. Any other direction, suppose this direction also possible. So many possibilities here. Okay, there is a direction, is a many possibilities, many planar possibilities here. So many plane of oscillation, many plane of oscillation are possibilities here. Okay, here. Okay. So now the sunlight also electromagnetic wave. So electric field direction in many ways. Okay, these are many ways possibilities here. So light beam which has vibrate. Okay, so light beam which has vibrate in more than one plane is called unpolarization of light or unpolarized light. Okay, so there is a many possibilities here. Okay, so in light wave, light wave, obviously wave or light beam, or say that a light beam, a beam of light which has vibration is more than one plane, is more than one plane. Okay, and is called, the plane is called unpolarized light, right? Light, this called unpolarization. Okay, so that's why here in case of this light electromagnetic wave is a unpolarized. Okay, there is a more than one plane here. Okay, so more than one possibilities here, so that's why these are unpolarized light. So if suppose and say that there is another if here, if a light beam which has vibration only one plane is called polarized light, and this only one plane is called polarized. This is called polarized because they have vibration only one plane. Okay, the light beam here the definition is that the light beam, or suppose a wave which has vibration, which has vibration is only one plane, one plane of propagation, one plane is called polarized light. Okay, clear. Now we draw a diagram for better understanding. Okay, go to the next page, and there is an X. Okay, there is a X, and suppose there is a Y, and there is a Z. Okay, so here the electric field in that direction. Okay, that's the electric field. Okay, now there is a magnetic field obviously here. So magnetic field in that direction. Okay, that's a B, and there's the electric field E, and so that's why these are unpolarized light. Why? Because there is a more than one possibilities here. Okay, there is a more than one plane. Okay, so what is our polarized light? Means there is only one plane. Okay, so now we put a polarizer. So what is polarizer? Polarizer is look like this. Suppose I put a one plane here, and this plane passes through. There is some blockage, some open here. This blue color line are open here, and white color is blockage. So this is called polarizer. This plane is called polarizer, and these polarizer block one plane. Okay, so they block passes the E part but block the B part. Okay, you see that they passes the E but block the B. So now after this light wave, suppose this light wave or light beam passes from this polarizer, now they have only E part, electric field part, not magnetic field, because B is blocked by the polarizer, and there is only one plane. So this light, this unpolarized light, and this light is called polarized light. Polarized light. This is called polarized light because there is only one plane here. Okay, and this is called plane polarized. This is another name is called plane polarized light, and this is also called a plane polarizer. Suppose it is called plane polarizer. Okay, so axis is that this is the axis. This actually axis belongs to the in Z parallel. Okay, so if the intensity of light, if I say that the intensity is here, that is I0. Suppose the intensity of that unpolarized light is I0. After passing that the plane polarizer, the intensity be the half I0 by 2, because there is a B part will be blocked here. So that's why after that light passing from the plane polarizer, so axial of that is Z axis. Okay, here. So there we get only a electric field part here. So that's the intensity be the half. Okay, that's the plane of vibration. Okay, this is called a plane of vibration. This is the plane of vibration. Okay, suppose the plane of vibration here. Now, if I put another polarizer, okay, suppose, and this polarizer is called analyzer. When you put another plane here, so this plane is called analyzer. So analyzer now look like, suppose analyzer, and this plane is called analyzer. Okay, these are not called polarizer, and there is another plane. So this plane is called plane polarizer, and this is called an analyzer plane. Okay, there is obviously a plane, and these are axis is that x axis, but plane vibration in z direction. So not totally block here. After the light passing from analyzer, we get zero intensity. We get zero intensity because the plane polarizer and analyzer, they are mutually perpendicular. Okay, so polarizer, this plane, actually name of this plane is polarizer and name of this plane is analyzer. So polarizer perpendicular to analyzer. Okay, polarizer and analyzer is a part of, so intensity here that is zero because the no light after the analyzer, there is a no light here because totally blocked here. Clear the concept? So if I little bit shifted here, there is a not 90 degree here because less than 90 degree. So some part of light here we get some part of intensity here because there is some less than 90 degree. If this angle between that polarizer versus analyzer, P versus A is suppose is less than 90 degree. So you get some part of intensity here. That intensity is greater than zero. The output intensity obviously greater than zero. Okay, clear. What is polarizer? Block some plane of vibration. Here this plane polarizer here block the B part, magnetic field B part, and the analyzer also the block the E part. Okay, so that's why we get some zero intensity here. So now describe from intensity and what's the direction. That's a Malus law. they states that when the completely plane polarized light, okay, actually these are the polarized light, okay, these are the, after this are the plane polarized light, because they actually the one plane here, okay, these are actually a one plane, not a single plane here, so that's why this light is a polarized light, okay. So when a completely plane polarized light, when a completely plane polarized light in incident uh, analyzer, the intensity of emergent light, the intensity of emergent light here, okay, emergent light varies as the square of the cosine, varies as the square of cosine of the angle between, of the angle between the polarizer and analyzer, the polarizer and analyzer, okay. So the formula is I, that is equal to I naught, that is cos, okay, that is the cos square theta. Theta is the angle between polarizer and analyzer. Clear? That's the Malus law. Okay. So if a angle slightly less than 90, so we get some intensity here. That's depending on the Malus law and this formula. Okay. Now discuss the polarization by reflection. That's very important. Polarization by reflection. Okay, that's very important concept. So suppose there is a some medium here, okay, suppose light, obviously is a unpolarized light here, unpolarized light, okay. Suppose there is a two-way direction, suppose is a dot represent towards me, suppose towards me, okay, the parallel to the plane of polarized, okay, these are called dot represent, suppose these dot, for these dot, okay, this dot represent the parallel to the plane of polarized, parallel to the plane of polarized. So after striking the back here, okay, so now there is a normal here, suppose there is a normal, and these are optical denser, so that's why refracted a bend towards the normal, okay. And you see that here this some dotted part here, and see the vibration here and here, okay, missing some plane here, okay, some part of plane here missing here. So reflected ray, the partially polarized here, so reflected ray are partially polarized, and here is a refracted ray, and see that this refracted ray is called dot, okay, and that is the perpendicular to the plane, and these are this line, yeah, and this line is perpendicular to the plane, polarized. Okay, and here you see that is a refracted ray is unpolarized. Okay, and you see the reflected ray is partially polarized, but refracted ray is unpolarized. This is an unpolarized light, incident ray, refracted ray, and unpolarized light. Unpolarized ray. So if and see that the concept is that the I incident angle. Okay, if I increase the incident angle, if I increase, so if consider I is increased, if I is increased, sometimes some angles, some almost reflected are polarized. Now, when I is increased, at some point at some angle of I, we get reflected ray fully polarized. Fully polarized. Okay, and this angle is called Brewster's angle. This angle is another name is called IB, and this IB is called Brewster's angle. Clear? So here that means there is a no one plane here. Okay, no perpendicular plane here. Okay, so that's why the one plane means these are the polarized light. Here we get polarized light. Clear? What is a polarization? Okay, it's a basic small part in our class 12 wave optics. Okay, so a very simple and easy concept. If you have any doubt, please ask in comment section. I'll try to give the answer. So today in the class here. Okay, thank you for your time.